Alright, so how's it going, everybody? Just received a new DC power supply. It's a IKococater. The model is SPPS C3010. So let's go ahead and open this up and see what it's like. Alright, so got our product certificate, warranty card, IKococater after sales service, 90-day warranty, and a 3-year replacement warranty. That's pretty nice. And then we have our user's manual. And it's not translated from, it's not translated into rough English, which is nice. All right, let's go ahead and unbox this. Let's see. We got our power cord. I am here in the US, so we got a US power cord. And so it comes with alligator clips. Let's see here. Ooh, that's light. Make this nice. And that piece. Oh, it's got a nice cutout packing. It seems to be packed pretty nice. Let's check all the buttons and everything. Now this is a 30 volt 10 amp unit. So let's see here. Oh, this thing is light. This weighs, I don't know, maybe less than 4 pounds. Rubberized feet, which look like they might actually have little screws in them with some caps on them. That's pretty nice. All metal housing. Good size cooling fan. Yep, 115 volt. Input, output is 30 volt, 10 amp. Does have a built-in fuse, which, let me see here. Let me go grab. Sorry about that. I had to go grab something to pop this off. Fuse fell out. Alright, so let's see. Oh, and they give you an extra fuse. Oh, yeah, there you go. Give you 2 fuses. This is the main one that plugs in, and it's got a little holder here for a spare one. Let's see. Just say it's a 5 by 20 millimeter 5 amp fuse. So, back in like that. All right. Now the one thing, this is a switching power supply. Oh hey, I didn't notice that at first. A cell service. Got a sticker right on it. That's nice. You don't see that very often. I did get this off of Amazon. It was, I think they had it listed as like $63, but right now at this moment, I ordered yesterday, January 4th, and today, 2023, and today's the 5th, and they have a 20% off online coupon for it. So let's go ahead and plug this in. All right, I'll be right back. Give me 1 second, guys. All right. Sorry about that. I wanted to grab my multimeter real quick. This one, one of the nicer features about this one, which kind of made me lean towards it, was not only that 20% off, but let me show you. You're able to individually adjust each number. Yeah. So it goes right up to 32 volts. But you're able to So you're supposed to push these in. You're supposed to be able to adjust the Okay. So the one thing about this is you're able to go to each individual by tapping the button. You're able to go to each individual digit and adjust it. And then down here is your amps, your current. Go ahead and drop it down. Like that one does. And then we just leave it for a couple of seconds. It goes off by itself. The only nice thing about this is it, there we go, get some of that glare off for y'all. instead of having to like short out the leads in order to adjust your voltage, it has an on-off output. So as soon as you turn it on, it's not putting out power. Turn it off, there's no power coming out of your terminals. Where some of them you have to have your terminals plugged in, short them out, basically drain the capacitors out is what you're doing. And then you're able to adjust the unit. Some I read about, you actually have to turn the unit off, disconnect whatever you're checking, plug them in, turn it back on, and then let's see. I'm just going to zoom in a little bit on that for you. There we go. So with no output, just connecting the clips. But turn on. You can see at 1 amp, it's only putting out 0.08 volts at 0.081 watts, which, that way you don't automatically, as soon as I disconnect, it goes back up to 3.4 volts. That way you're not, you don't accidentally fry something you're testing on by plugging it in and forgetting to disconnect leads or something like that. Can go from constant current to constant voltage. Go to 1.5. So you can see we're on constant current right now. We're going to hook up our leads. Output. Okay. Disconnect. Now it switches over to constant voltage once we disconnected the leads. Constant current. So we're putting 1.1 amps through the leads right now at 0.09 voltage, and it's 0.099 watts. Disconnect. Switch back over to constant voltage. Just sitting at 3.5 volts where we set it. It does have a ground lug. Will have a binder between these two, basically a piece of metal. That really is not going to give you a very accurate reading. So you leave them unbonded. And this actually is like earth ground, not negative, as most people would know it as. So let's go ahead and turn on our voltmeter. Alright. And then we will check our voltage. So I think there we go. It's a little bit better. Leads. So we got positive to the positive probe. Alright, here got negative. And that's saying 3.524, where our unit's set at 3.5. So let's bump it up. 4.52. Let's go right to 10. 10.51. Wow. That is really accurate for I mean, for how cheap this was. I mean, that's accurate. So let's go to 20. 20.51. Wow. So let's take it up to 30.5. 30.5 dead on. Wow. I'm really surprised, honestly. I mean, that's just 1, 2, 3, 4, 5, 6, 35.1, 35.6 on the unit. Hopefully y'all can see everything. Still right at the top end. It's 30. What is reading? 30.01. Wow. We're gonna drop it down to. Takes a little bit to bleed off, but as expected because the capacitor is going to have to discharge. It's showing discharge. My meter's still going down. I mean, let's go ahead and see here. It's probably not going to totally discharge all the way because you do have power running through it. But I'm going to turn it off. The output. Actually, let's go ahead and get back up to something we can read. This is 10 volts. Output 10 volts dead on. Turn it off. There you go. You can see it's draining off now. So let's put this up to 5 volts. Let me swap over my meter here. Go ahead and check the amps. Alright, so output. Got set at 5.1. Is at 5.93. 6. It's pretty close on amperage. Get it right to 10. 9 point. Dang, huh? And right up to the 10. So this is spot on, really. I mean, that's incredible. Sorry guys, I keep raising it up a little bit too high. Keep looking at it. Let's so like I said, 2.02, I'm reading 2.018. So really, like I said, 2.05, 2.048, so that's really close enough to 2.5. Let's go up to 2.55. 2.546. I mean, that's accurate. Hit the power off, drops right down to 0. Just like that. Does have a 5 volt 2 amp USB port, so you can plug in your cell phone, you know, or some other device to charge. Or probably, or even whoops, dang it. Or even use if you're using some sort of USB powered device for diagnostic tool, you know, for like phones or you know, stuff like that. Let me go grab something real quick and let's try something out real quick. All right, so I went and I grabbed an LED light. Just a simple little LED light. Gonna separate these legs a little bit. Hook on our positive. Hook on our negative. Let me share. Yeah, look at that. One, that. Two, there it goes. There we go. You can see it's very bright. It's putting out 0.0, goes anywhere from 0.09 to 0.02 at amps to from 0.18 to 0.42 watts. That's at 5 volts on this thing. It's not burn out any LED here. You see it gets softer with the voltage. Oh, just burned out my LED, but you all saw that. Works pretty well. It's alright, just a scrap LED. Yeah, so that's, I'm gonna turn the voltage off. That's pretty much it. One thing I have done some research on with these is when is because they are switching because they are switching power supply versus a linear, the noise, electrical ripple coming off of it, this is being fairly messy. And from what I understand, it tends to happen to be the MOSFETs inside the unit. I haven't really had a chance to open this up, as you all saw. But one thing that I was learning was that usually what's happening is the MOSFETs are opening and closing too fast. So what people I've seen are doing and reading about, they've been doing, is what they're doing is they're slowing down the MOSFETs in it. Now, on a board, on a PCB board, MOSFETs have 3 spots. They have a gate, a drain, and a supply. And what people are doing is they're going in and they're putting a resistor in the gate trace of the PCB. And then what they're doing is they're putting a capacitor across the gate and the supply lines. And that seems to be cleaning up the noise, the uneven spikes coming out of the unit itself. So you're basically getting a lot more clean power. What I've seen so far is people are putting in roughly a 30 ohm resistor on each MOSFET gate line, as well as like a 40 to 50 nanofarad capacitor between the gate and the supply. I don't know anybody off the top of my head that has an oscilloscope in order to actually test that out. I am going to look at it, look around, see, talk to a couple of buddies and that, and see if they do have somebody that does happen to have an oscilloscope. But give me a moment. I keep forgetting stuff in the other room, but I'll go grab a screwdriver, and what we'll do is we'll go ahead and open this up real quick and take a look at it. Just seems to be 4 screws on this side and 4 on this side, and that top should just pop right off. So give me a second. Let me go grab a screwdriver. Let me go ahead and unplug this real quick. So you can see it stays on a little bit. What's happening, even though it's unplugged? What's happening is those capacitors are draining. So even with the switch off, so it does not have a master on-off switch in the back here. Just this little switch here. So even with this switch off and no like main power switch to actually cut the electrical as soon as it gets into the unit, the whole time this is plugged in with power going to it, it is energized. It does have power in it. You know, you always want, I always like to have that extra backup safety feature. But let me go grab a Phillips screwdriver real quick and we'll take a look at this. Screws in there nice and tight. I'm gonna grab a different screwdriver. This one does better. There we go, that's better. Just gotta grab the right tool for the right job. Makes it so much easier. Oh, this one is really tight. There it goes. Alright, there we go. So there's the inside of it. And your power supply. Got some nice big caps. Chain caps. Nice big. Turn this around for you. Big heat sink on the PCB. You got plenty of space under there. This is the front plate PCB. It's got a couple of spots for. It's got a plug there. I'm not sure what that was for. If that's what it's even used for. It's not for this unit, so I'm sure they probably use these for different things. Power wires coming in are heat shrinked. Zip tied right there. So I'm not going to tear too much into this, but just I have to get in and look at this and just see some more. Yeah, put this up under the microscope. See where the MOSFET traces go in that, because our should be some MOSFETs in here. No. Can't see those. Can't see them through the back of the board. Ground is screwed in and crimped. Right to that metal bracket. Just screwed down with these 2 screws. But they're using some very small microscopic filters and all that in here. This is a little different than some of the others I've seen, where they're not using such small filters and stuff. I mean, these are the size filters that you're going to find in iPhones and Android phones. You know, these filters and little capacitors and that. So I'll be interested to see if I can actually find somebody that does have an oscilloscope that we can put this on and test it, because I'm really interested. These must be my 2. Just trying to see real quick if I can see where. So, but it still looks like they've got. Oh, okay, so. Alright, well, that's pretty much, like I said, well, as far as I can see real quick on this, it's a little different than the ones I've seen, where you'll have like 2 big MOSFETs back here with big heat coils on them. It's real easy to trace where your gate, supply, and drain are at. I can't really do that in here, just looking up under the lights here. I gotta really tear this down and put it up underneath the scope and trace everything. Because you want to be able to find that. I might, you know, we'll have to, hopefully I can find somebody with a scope, trace, see if there's a certain point where it is putting out a lot more, see how clean it is to begin with, and then put out, see, you know, do a short out test lead test and sniff around, see if there are any spots putting out a lot more noise than other spots, and then that's a place to start looking. But that's it for now. I'll put the link in the description for this. Like I said, I got off of eBay. I'll put the make and model number and the link. This multimeter, I'll put a link into it since I used that as well today. Got that off of Amazon as well. But if I find out anything about it, I'll give you all a follow-up on it. But until then, enjoy.